Hey y'all. Today we're going to take a look at solving a quadratic equation by completing the square. The three methods that we know so far are the graphing method, the factoring method, and then taking the square root. So today I'm going to show you how to solve a quadratic equation by completing the square. So let's go. So we already got the 8 steps up there. It seems kind of long, but the more of these you do, you'll be able to kind of like flow with it, and you can kind of shorten some things. But the first thing we want to do is make sure the quadratic is in standard form. Move the C term to the right. Take half of the B term and square it. Add that amount to the left and the right side. Write the left as a binomial squared. Simplify the right. Take the square root of both sides and then get x by itself. One thing that I do want to show you before we jump into things is what does it mean to, like, what is this square term that we are trying to think of? So suppose that I had a trinomial, and it's up to you if you want to write this down. It's kind of like a little side note. Suppose I had x squared minus 6x plus 9. Okay. 9 is a perfect square number. So since 9 is a perfect square number, when I factor it, it's going to factor into the same thing twice. So this is going to factor into x minus 3 times x minus 3. So when this number here, and it's your C term because it goes A, B, C. So A is 1, B is negative 6, and C is 9. So when it goes A, B, C, this last number, you want to try to make that number be a perfect square number. And so since 9 is a perfect square number, it factors into the same thing twice. So there's this process called completing the square. So the square comes from, think of like the box method way back when. Okay, so this would be x minus 3 and then x minus 3. So what the whole goal is to get this number to be a perfect square number. And you do that by taking half of this number and squaring it. So your 2 steps, and we're going to work out some problems, so don't worry about that if you don't get it verbally. But your 2 steps to completing the square are to take half of this number and square it. So half of this number is negative 3. And negative 3 squared gives us 9. So we have made it a perfect square number, a perfect square trinomial. So now let's solve some problems. And let me put the 8 steps in viewing range there for us. Okay, here we go. So step 1 says put the quadratic in standard form. So standard form, it has to go x squared, x, and then your number. So check. We're done with step 1. Step 2, move the C term to the right. This is your C term. It goes A, B, C. Move this to the other side. This is positive 11. We need to subtract 11 from both sides. So that's going to give me x squared plus 12x. I want you to leave a little space equals negative 11. And you'll see why in just a moment. So this is step 2. Move the C term to the right. It goes A, B, C. Take this and move it over to the other side. And leave a little space because we have to complete the square. Now, the actual completing the square part has 2 steps to it. And I really want you to write those 2 steps out. So step 1, we take half the middle number. So half the middle number. So in this case, my middle number is 12. So half of 12 is 6. So I'm going to write 6. Okay. Step 2, squared. So 6 squared is 6 times 6. This gives me 36. All right, so I strongly encourage you to actually literally write your 2 steps out to the side because you'll see why in a few minutes. It's going to help us in the middle of the problem. So take half of the middle number. Half of 12 is 6, and then we're going to square that number. 6 times 6 is 36. Now, we got to keep our equation balanced. So I'm going to add 36 here. And I'm going to add 36 over here. So that's why I encourage you to leave a little space, because we're purposely trying to put a perfect square number in this position. So we added 36 and we added 36. You got to add 36 to both sides because you have to keep your equation balanced. And what you do to one side, you got to do to the other side. So if I'm following my steps up here, we've done step 1, 2, 3, and 4, because it says add that amount to the left and the right side. Number 5, write the left side as a binomial squared. So, for example, x minus 3 times x minus 3, x plus 4 times x plus 4, x minus 7 times x minus 7. So I now need to factor this. Two numbers that multiply to give me 36, add to give me 12. So those numbers are 6 and 6. And go ahead and add this side. Negative 11 plus 36, I got 25. Now I can condense this and write it as a binomial square, which is what step 5 says. Write the left side as a binomial square. So I can go ahead and square this. X plus 6 squared equals 25. All right. So we're on step 6. Simplify the left side. Actually, we've already done that. So simplify the left side. I can't do anything to it. It's already simplified. Step 7, take the square root of both sides. So we're going to take the square root. Take the square root. So this gives me x plus 6 equals plus or minus 5. So x plus 6 equals plus or minus 5. Now, I'm going to set up two different equations so I can get my two different numbers. X plus 6 equals positive 5, and x plus 6 equals negative 5. So x plus 6 equals positive 5, x plus 6 equals negative 5. Again, I'm right here. X plus 6 equals positive 5, and x plus 6 equals negative 5. And we're going to go through and solve each one. Subtract 6, you get negative 1. Subtract 6, you get negative 11. So these are our two answers, negative 1 and negative 11. So our two steps when you're completing the square, because we purposely want to make this number be a perfect square number, you take half of the middle term, which is your b, and then you square that number. All right, let's go over and try the next one. So we'll follow our steps. It says put the quadratic in standard form. So x squared, x, and then your number. So check. Step 2 up here, move the c term to the right. Your c is your constant. So you can think of that c for constant. This plus 19 is in the way. We need to move it to the other side. So that's going to give me x squared minus 8x, leave a little space, equals negative 19. So x squared minus 8x, leave a little space, equals negative 19. Now, off to the side, we are going to complete the square. So off to the side, I'm going to write my two steps out, and we're going to complete the square. So step 1, take half of the middle number. My middle number is negative 8. Half of negative 8 is negative 4. Okay. 2, square that number. So square it. Negative 4 squared means negative 4 times negative 4, that's 16. So we need to add 16 on the left side, and we need to add 16 on the right side. So we're adding 16 to both sides. Adding 16 to both sides. What you do to one side, you got to do to the other side. So we added 16 to both sides. Now we need to factor this. And since this is a perfect square number, it's going to factor into the same number twice. So this is going to factor. We'll set up our parentheses. Two numbers that multiply to give me 16, add to give me negative 8. That would be negative 4 and negative 4. Go ahead and add negative 19 plus 16. Add that together. You get negative 3. Now we are on step 5. Write the left as a binomial squared. So step 5 says write the left side as a binomial square. So it should always factor into the same thing, which means we can shorten it and make it just be x minus 4 squared equals negative 3. The opposite of squaring something is to take the square root. So the opposite of squaring is to take the square root. So here we go. So x minus 4 equals, all right, I'm going to do a couple of things here. We know when we take the square root, it's going to go ahead and have the plus or minus. And I have a negative on the inside here, which means we need to take out the I part of the problem. And I cannot break down 3 any more than it already is. So here we are. And the last step, we are trying to get x by itself. So when you get x by itself, we need to do the opposite of this. So we need to add 4 to both sides. When you add 4 to both sides, it does not go inside of this square root. So when you add 4 to both sides, it does not go on the inside of the square root. They are not like terms. So my final answer is x equals 4 plus or minus I square roots of 3. That is our final answer. Okay. All right, we have a couple more that we're going to go through and work out. So x equals 4 plus or minus I square roots of 3. All right, let's take a look at C. All right, so step 1, put the quadratic in standard form and step 2 says move the C term to the right. So some of that has already been done for us, so life is a little easier. We have a little less steps that we need to worry about. So x squared plus 5x, and our C, our constant, is already to the other side. So we're just going to do x squared plus 5x. We're going to go ahead and leave our little space equals 1. Off to the side, we're going to complete the square. Okay, step 1, take half of the middle number. So my middle number is 5. If you take half of 5, you're going to get 5 halves. So 5 divided by 2 and leave it in fraction form. So we get 5 halves. Now square this number. So 5 halves squared means to do 5 halves times 5 halves. This gives me 25 fourths. So this is our C term that we're adding to both sides. So we're going to add 25 fourths here. And we're going to add 25 fourths here. So this problem is going to be a lot messier than the other ones we did, but that's all right. We're still on the right track. We took half of the middle number, and then we squared that number, 5 halves squared. Now we'll go ahead and set up our parentheses, and we need to factor. Now, this is the reason why I strongly encourage you to write out your steps off to the side. So this is why over to the side, I do my CTS step there. That's why I did it up here for the first one. And I did it for the second one. If you write your steps out, when you try to factor it, it's always going to factor into your number 1. So for this particular problem down here, we're looking for 2 numbers that multiply to give me 25 fourths, add to give me 5. That's kind of difficult to do. I mean, those aren't regular numbers we work with. So 2 numbers that multiply to give me 25 fifths and add to give me 5, that's not normal, so to speak. But if you write out your 2 steps, it'll always factor into number 1. For example, my number 1 here was 6. Notice it factored into x plus 6 and x plus 6. My number 1 here was negative 4. Notice it factors into negative 4 and negative 4. So down here for letter C, since I'm trying to factor it, it's going to factor into 5 halves both times. So 5 halves, 5 halves. From here, we go ahead and add 1 plus 25 fourths. That gives me 29 fourths. And from here, we can carry on. We can condense the problem. I got 2 of the same factors. You always should have 2 of the same factors. So x plus 5 halves squared equals 29 fourths. The opposite of squaring something is to take the square root. So I'm going to square root this side and square root that side. That's going to give me x plus 5 halves equals the square root of 29 fourths. And well, actually, it's going to give me plus or minus square root of 29 fourths. So don't forget that plus or minus. All right, now the last thing that we can do, I have this plus 5 halves here. We need to subtract that from both sides. So I have a positive 5 halves. We need to subtract from both sides. So x equals negative 5 halves plus or minus the square root of 29 fourths. And technically, I do want to show you one more thing. 4 is a perfect square number. So since that's a perfect square number, I can rewrite it like such. So now I have this as my answer. So this problem was a lot more involved than the other problem, only because we had that fraction in there. So this fraction kind of threw us off. We had to keep simplifying. We had to keep simplifying. So when I got down here to this 4, 4 is a perfect square number, so I can take the square root of 4, and that'll just become 2. So I can write it just like this, okay? In the next video, I'll show you how to do D, because D is going to work out a little bit differently. We're going to have one additional step that we're going to have to do for D.